Hello, everyone. Thanks for joining us. Um, Rami here. Hello, Kit. How are you?
Well, thank you. Thanks for having me.
Yeah, for sure. We've been kind of brewing on this for a while. We've been chatting a bit and actually, yeah, excited to kind of share even how we came about running into each other. But for everyone here, thanks for joining and looking forward to sharing more about what this is about in terms of different materials and sort of why maybe they're not so different, right? And how familiar we can actually be about them. But before we get into the nuts and bolts of all this, let's maybe talk a bit about ourselves in terms of, who we are and how did we, get to this. So, Kit, where are you joining us from?
So I live in the Bay Area, in California, and I used to live in London. I moved out here 2 years ago. But yeah, I lived in London all my life, working on different projects and different sectors. But yeah, enjoying my time in the West Coast.
Awesome. Yep, that puts us 2 hours apart here, me being in Austin. Fortunate for us, all the time change has been constant for all of us. So
Yeah, yeah,
that's
yeah.
that's been a good thing. Yeah, that's nice. So being there in the Bay Area and sort of working on what you're doing with BioTwin. So before I guess we talk about BioTwin, for everyone also joining, we're gonna kind of switch it up in terms of how we set the flow to this. So, in terms of what this material is, we maybe want to take a step back and take a bigger picture kind of perspective on what is the state of material innovation today, right? And what does it actually mean to have a different material composition, the chemistry itself, or how it performs. So, let's maybe take a step back and share a little bit more about like what does bio-based material actually mean?
Or is that a question to me?
Well, I mean, if it were for the audience, maybe. But yeah, tell us.
Yeah, so we're dealing with natural fibers and combining it with another material, and that's a composite. Um, when we talk about bio-based materials, I mean, there's actually lots of different definitions, and I'm actually part of the bio-based materials collective. The audience might know of them. And they're actually putting together definitions of what bio-based means.
Hmm.
There are definitions in the US that's slightly different to definitions in Europe. And from a manufacturer's point of view, we have different definitions. I think broadly speaking, we're talking about natural fibers or uh, materials coming from nature. Um, that's broadly how we define it. And then when you combine it with um, another material, then it's a composite
Hmm.
or composite, as
Yeah,
the US would say.
yeah,
So that's how we broadly define it.
yep. And that's eventually when a lot of times with bio-based materials, it might be contextualized with circular economy and sort of like how when for many of the architects today and really anyone keeping up with most requirements, right? So on the regulatory side, we've seen how EPDs for products are a thing, right? And that's something you've pursued with yours. But in terms of end of life, right, and sort of how the circularity of a material, not only from its raw material sourcing, but also about how it then recycles back in as needed and essentially optimizes for what end of life actually means. Because it tends to be an issue sometimes, right? Material waste in general. So,
I think that's a good point there, is that the conversation has moved on from, okay, you're using bio-based materials now, but what happens at the end of life? Um, I think there are a few folks out there now that um, have moved the conversation further and want to understand now, okay, we're using this particular material. How does it go back um, into itself? Or can it be recycled or even better, reused, right?
Hmm.
So the conversation has moved on, advanced a lot more than, okay, we're using low carbon materials, but how can we sustain that further and keep it circular?
Yeah. And even from a regulatory standpoint, right? I mean, from my experience and having talked to quite a few who are interested in specifying more materials that, in some cases, the clients encourage it and actually desire to have something that's, in terms of environmental impact, to be as minimal as possible. But then again, it might also just be about looking for something that's different, but in a way has its benefits. And so, we've recently seen, we were just talking about this earlier too, in terms of, so I'm in Austin here, and they recently approved, from a building code perspective, that, let's say, hemp-based products are a viable choice for construction. And really, what it is about is for someone not to roll their eyes over when they see something they're not familiar with in the construction documentation, right? And all these sets that go through the permitting departments. So really, it's about also we're very aware of the challenges that come with substituting or specifying materials that maybe are less familiar to certain jurisdictions. But we're definitely seeing a trajectory on the other side, which is more familiarity and uh, you know there is proof for why it's a viable option.
I would say that on a macro level, we're seeing governments around the world push this a lot further and setting embodied carbon limits. So Western Europe is a prime example where they're a little bit further ahead, and they've set limits for developers and people doing retrofits.
Yeah.
That's filtering through other countries around the world. California is the first state to set embodied carbon limits.
Hmm.
And I would expect this would continue, even though it's quite slow. You're relying on the government to push this agenda forward. But I would say on the other side, from the demand side, you also have corporate tenants, and they have or corporates in general, they have ESG targets,
Yeah.
and they're demanding to be in greener buildings. So then that adds pressure to commercial building owners to think about, okay, how do I retrofit my building? Or how do I have sustainable materials in there? Which leads
Hmm.
then onto green certifications like LEED or BREEAM and WELL. And earning those certificates does add a bit of premium. And so corporate tenants don't mind paying that if they know that they're hitting their ESG targets, but also improving um, the well-being for their employees. Because everyone wants a greener building, quieter,
Yeah.
and more productive environment to work in.
Absolutely. I mean, that's exactly the case in many ways, is that it's oftentimes something you feel in a space. And I think for many, we've maybe walked through buildings where maybe we saw the plaque somewhere at the entrance where it shows like what certification that building got. And more often than not, you will feel the difference. Like you definitely sense either the air, so it feels cleaner, right? And there are all sorts of certifications where they measure for that depending on but then the materials themselves, right? The low to no VOC, so the volatile organic compounds. So basically things that we shouldn't really be breathing, but in all fairness, you would sometimes just think that, well, is the air outside not as good, and then you'd realize that it gets into a whole different conversation, right, in terms of air filtration and things of that nature. But the materials themselves play a big role, right, for sure. And so, yeah, that's definitely one of the maybe best benefits in terms of the air quality component to bio-based materials is that they tend to really comply very well. And if anything, be on the other side where maybe there are filtration properties too sometimes. Um, but in the context of BioTwin, so let's dive into BioTwin and talk a little bit more about the journey. Uh, I think I myself haven't really asked you that thoroughly in terms of like how things came about, but what was the spark, I guess? Like what made the like elements in terms of what you and the co-founder were doing at the time, and sort of what sparked the kind of inspiration, I guess, to even targeting it in this angle.
Yeah. And before we dive into that, a little bit
Sure.
of background information on myself.
Yep.
So I've always been involved in tech and online marketplaces. So in my corporate background, I used to work in tech PR, working with blue chip companies like Oracle, Microsoft, LG, Nokia in their heyday, when they were number one
The
in the
N
smartphone
series is
area.
unforgettable. Let's just say that the N
Yeah,
series was a staple of its time for sure. Yes.
exactly. But yeah, I was in PR for about 7 to 8 year period. Then I moved in-house, and that was at agency level. So I was kind of working with multiple clients. I moved in-house, worked for Alibaba for 3.5 years, mainly for the Alibaba.com platform, which was really facilitating the relationships between global buyers and global suppliers.
Mm,
So if you're looking for manufacturers around the world, not necessarily in the Far East or Southeast Asia, you could find any manufacturer on the platform. So just helping those buyers find the right ones, facilitating the transaction and the relationship there. So that really helped me understand how online marketplaces work. And then I kind of left after the IPO, still the largest IPO in history at Alibaba. But I
mm-hmm,
left there because I felt like a small cog in a big machine. Set up my own marketplace, but focused on beauty, really connecting beauty therapists with the customers directly. So you could have your treatment at home or your office.
mm-hmm,
Exited that after being acquired by a competitor. Then started getting into property, investing into kind of single family homes. Started building a portfolio and then spun out a property management company. Did
mm-hmm,
that for a few years. Also acquired by a larger competitor. And then I was really doing kind of this soul searching thing of what do I want to do next? I didn't want to really just get into another tech platform, and really just try to think about things that I wanted to do in the future. So sustainability or the environment is something that's quite close to my heart. Education was also one area that I wanted to venture in. But I landed in kind of the environment, started doing some research, and I came across this accelerator in London,
mm-hmm,
and it was super focused on sustainability, and I thought, why not? And that's where I met my co-founder, and that was 3 years ago, in London, and yeah, and that's where the journey started with BioTwin. We came together, we wanted to do something in the construction sector. He had more experience on that side, having set up design studios, furniture making businesses,
mm-hmm,
manufacturing in the Far East and in Eastern Europe, and also doing retail fit out. So he understood that world, and I thought I could bring the business side and help commercialize the product. And we just started off with something small. We thought, okay, well, could we make a lower carbon version of a building component, and where could we start with? And we just started. We just came up with wall stud because that was commonly found.
Yeah.
There's lots of walls in a building, and we specifically chose the partition wall because there's a little bit of leniency, I guess, or less scrutiny around partition walls. Like it's not structural. Um, there's different types. Does it need to be fire rated? Does it need to have acoustic performance? So we thought that's maybe a good entry point for us,
Hmm.
um, and start off with that. And initially, we wanted to do something with bamboo. We quickly switched to a different material
Hmm.
because bamboo is not widely grown everywhere, and so we started thinking about different materials that we could get access to quickly, or there was a huge
Yeah.
abundance of it. And so we chose hemp, and specifically the hemp fiber and the hemp hurd. Hemp hurd
Hmm.
is underutilized, quite commonly used in animal bedding, but some farms consider it as waste. It's starting to be used a lot more in, say, hempcretes. We've seen that take off.
Hmm.
But the hemp fiber is what is, I would say, the the premium value of the plants
Hmm.
is the fiber, and so we're using that as part of our products.
That's amazing. And it's actually what I love hearing is the observation around, I mean, with office in particular and just like building fit outs, when we look at it from a scale, and I don't have statistics on this right now, but there are plenty that I've seen, just also doing my work in terms of observing the market and seeing trends. And office fit outs tend to happen quite a bit, right? As leases either renew and then each occupant has a new ambition to what they want the space to be. So the whole renovation and the whole just retrofit of the space itself becomes a serious concern, and they get expensive pretty easily, right? And that's one of the main things too to consider is that like we're in this time where the use of a space is in constant flux to what society in that region demands, sort of, right? Or what there's a higher demand for. And so that's never static. So this constant motion is a very good like an angle in that sense. Um, it's kind of interesting to hear also the shift from bamboo to hemp in the sense of product availability. So I think availability is always a concern, right, in terms of the manufacturing of things. Um, is it worth maybe scratching the surface on that just a little bit, and maybe just to give us some view on things? So actually, what I'm gonna do a little bit is I'm going to shift our screen here, and I'm going to start showing how the material is actually made. So in this case, we're seeing the herd processing, right? So you guys filmed a very nice how it's made kind of thing. Almost felt like I was tuning into Discovery Channel and watching the actual making. But in this case, we're seeing the hemp herd getting processed there. And so what's the realistic perspective on the availability of hemp herd in this case? And like sort of you mentioned before we went on live here, the availability of the machinery and all that sort of stuff. What are some quirks there that we might want to be familiar with?
So if you've got a hemp farm, um, that would, the hemp will be cultivated, and then you're using machines to decorticate the fibers and smash down the herds. So you're left with a lot of biomass essentially. Um, with the hemp herds, some places can't get rid of it, and so there's either burnt down, or they're giving it away in some cases.
Mm-hmm.
But what we realize is that it forms the essential core of our product. It helps with integrity, stiffness as well. Um, and so, yeah, some farms would have an issue trying to get rid of the hemp herd. Like I said before, the fiber is the thing that they get a lot more money from.
Mm-hmm.
With the herds itself, it comes in different chip sizes. So if you think of just like wood chips,
Yeah.
it could be, half an inch wide, or you can sometimes get an inch wide. Um, I think some places do sort it out into different sizes or can mill it down into a size that you want. For our product, we're not fussed with the different sizes because it all gets compacted down anyway.
Yeah. As
Um,
mm-hmm.
yeah. So I think for some, if you're looking for specific um, size, then yeah, you would need to go to a processor to then get, that particular chip size. But for most farms and processors that have the decorticator machine, they'll just extract the fiber, the hemp herd, bag it up, and then sell it to whoever needs it. They may have a process that you go further down where you might want it refined, and that actually leads to us. We take the fiber and we don't just take it as raw form. We actually purchase the non-woven fiber. What that just means is the raw fiber gets taken to another processor who needle punches the fibers together. And we generally just take 100% hemp fiber, but there'll be some places that would blend it with another material. So you could have 50% hemp fiber and maybe 50% synthetic fiber, like a polypropylene plastic.
Mm-hmm.
Um, and people will want different blends based on what kind of outcome they want
Yeah.
or they want. So
No problem.
for the automotive industry, they will use a blend of flax or hemp with a PP plastic, and then they'll just melt down the plastic. It gets all coated um, with the natural fibers, press it into a mold, and then you'll see not many people know this, but a lot of the EVs will have hemp or flax boards as part of the car panels,
Yeah.
uh, interiors of the car itself, so like the dashboard or the trunk, or even sometimes the lining of the seats.
Yeah.
So for their purposes, they need to have a blend of a natural fiber with a synthetic fiber.
Which is probably worth noting that the automotive industry has learned from the mistakes in the past, because in the 80s, I believe, 80s, 90s, Mercedes actually had this innovation where they were trying to reduce on the materials, that they were using. And so they ended up using a form of bioplastic around the electrical wiring, and that thing decomposed over time. So the thing is that we learn from these things, but just worth mentioning the sort of like the realisms behind, or the realistic kind of practice around implementing these has happened for many years, and like there's this constant push to do it. But what we obviously learn also from mistakes, but that was like one of the things that was very interesting. And of course, with plastics, they're bioplastics of all kind, and they've only improved in the recent years, in terms of even how the deterioration happens in its life cycle, and its use for the environment it's going to be in. And as we look at when as these so BioTwin is the company, but biostuds is what the product is, right? In terms of like and when we notice like the pressing of the boards, right, and you end up with these boards, um, as you get into the heating, I believe, so like it goes through this machine, I guess, that's slated for what looks like a normal size kind of plank of wood, right? And they get heated at a certain temperature, and they get formed in that sense. So just in terms of bringing the automotive industry into it again, um, we've all seen the Cybertruck, as most have probably like kind of questioned its shape, form, however we want to label it. But I think what's interesting is many miss is that the design concept behind it was that they were trying to make the most out of a metal sheet that they would get to process the vehicle and in this case the shell. And that's for many reasons it ended up achieving a very high productivity out of like each metal and they reduced the wastage on it. So in this case with the boards, would you say that it's kind of similar to in the sense that you're using the whole board, there's no wastage whatsoever because the sizes are properly dimensioned?
And that, and also increasing output and also improving the efficiency. So having these kind of 8 by 4 sheets, 8 foot by 4 foot sheets, we can then just cut them down into strips and then reheat it and then form it into the C profile.
Mm-hmm.
Um, it's easier that way than just doing it by strips because then yeah, there's a lot of wastage, and also you're having to heat up every single strip and press every single strip. We're just taking cues actually from uh, 2 industries in particular. Actually, the cold forming industry, where how steel studs are made. We're just taking cues from them. Very large sheets, cut down into several strips, and then quickly formed. Right, they just bend it, and out it shoots out. So like every few seconds, you're getting a stud.
Mm-hmm.
And we're taking cues from the wood paneling industry as well, pressing it with into very high density board, so that you get integrity there and also
Mm-hmm.
good tensile strength. But there's right now no one's doing a blend of those. No one's bending wood panels into a shape. You can press it into a mold and get some really good 3D shapes. For instance, the paneling of your kitchen or cupboard spaces.
Mm-hmm.
They're pressed into a nice mold and you get some nice detail on that. But bending it into a profile, that's where we're taking cues from the steel, cold form steel industry.
Mm-hmm.
So that we're blending across different industries. We're taking some cues from also the automotive and what kind of materials they're using. So we're learning a lot from different sectors, and how do we combine all of that then produce a product that's applicable for for um, yeah that particular use,
Mm-hmm.
and how can we do that in a repeatable way and consistent
Exactly.
way as well.
Yeah. I mean, fundamentally, for any building product manufacturer, even in this case, we don't have to talk about it in a very one-off instance for your particular situation, but the accessibility of manufacturing the product is key because as scalability gets to be a valid trajectory, you want to know who could you partner up with, who could potentially also, the whole licensing business of products is a thing for sure. And so, not hinting on anything here, this is not like this is the roadmap, but it's just very likely that those considerations are critical to working with partners and being able to scale these things. Um, so
Okay.
as
Yeah,
we've,
No, I was just going to add to that is that yeah, when we looked at the product itself, it was all well and good making a prototype and taking it out of a lab and producing a few, with our own machine.
Yeah.
But I think after looking at that, you want to your point, you want to look at, okay, what facilities are out there right now, and how can we utilize that, and not having to adapt any of the parameters or their machinery settings, because what we found on that journey is when we speak with manufacturing partners, they're willing to do a trial as long as you don't break their machine, and does this have upside for them? Like, can they move away from what they're currently doing and look into a new revenue stream? And so that's exciting for them,
Hmm.
also exciting for us because we get to use their machines.
Yeah.
Um, but at some point in the future, we also have to think about how do we control our own destiny and also produce these ourselves,
Hmm.
because you don't know what will happen with the manufacturing partners.
Absolutely.
Someone actually told me this, is that they could be acquired by a private equity firm, and all of a sudden they don't want to work with you, and
Yeah.
so then you're
However,
stuck,
they're
right?
you're on the chopping block of some reason. And yeah,
Yeah,
especially yeah, the PE business for sure, they definitely can. I mean, that's fundamentally where it's also a matter of timing there, right? Depending on the partners and how they do their diligence for sure to knowing which and what. But I think what's interesting, you bring up the manufacturing side, and I want to use, I believe they're called Chop Value. And their business is that they recycle chopsticks from restaurants where chopsticks are commonly used. You can only imagine it wasn't from a steakhouse, so there is that. But the chopsticks are recycled, and they press them, manufacture them in a way to create really nice, very the texture is amazing in terms of the wood. Essentially boards that they create, and they do all sorts of furniture with it right now. They do tables and things like that, and it's quite amazing that you can actually still see how they used to be chopsticks. And so, but my point with that is they recently opened up a manufacturing warehouse in the middle of a city. And what that made me realize is that when we're dealing with materials where emissions aren't really a concern because the manufacturing method itself has no impact in that sense, it becomes a very viable strategy to start considering, well, can this be manufactured somewhere where maybe it's actually closer to where it needs to be? And I think that's a very interesting sort of perspective because in many cases, with even the urban zoning shifts that are happening now, a lot of cities are being more flexible with how their zoning regulations kind of support or set barriers, right, to these kinds of innovation. But with time, it will be very proven how these manufacturing methods have or cause no issue, right, in an urban context. And it opens up opportunities, in this case, for manufacturers like you, and right, and for sort of how things go together. But I thought that was like an interesting kind of adjacent thought to sort of, what does manufacturing a product mean in terms of even where, right, and how. Um, but you mentioned the material, like performance aspect of that. So for anyone listening to this or anyone maybe reviewing highlights around it, that's always going to be a critical question, right? So maybe we want to set the right expectations that, first of all, this is not a load bearing, right? So this is a non-load bearing framing component. Um, and in fact, you've already piloted this, I believe, right? Is that the case? Like you've already kind of assembled it together and things like that. Tell us more about that kind of journey and how you got people together actually to kind of understand it and put things together.
yeah. So yeah, before I talk about the pilots,
Sure.
just some I guess some detail about the product itself. So we call it BioStud. We essentially have engineered a stud to replace the steel ones in partition walls for commercial buildings. And
Mm-hmm.
this is where we would typically find the steel studs. So we're not trying to replace the typical 2x4 in residential homes, because that's all timber framing. Where we slot in is where you have the steel framing, so you have the top and the bottom tracks, U channels, some people call them,
Mm-hmm.
and we slot in nicely into those. So you could remove the vertical steel studs and put ours in place. Currently, we go up to 2.6 meters, which is around 8 feet, or just a little bit more than that. Um, and yeah, we're not going into load-bearing walls. Starting off with the non-load-bearing ones, where we have on the improvement side over a steel stud, we're currently 71% lower in carbon than the steel stud, and also 25% lower than the recycled steel stud.
Mm-hmm.
So, there are a lot of contractors trying to switch over to a recycled ones. They are more expensive. If it helps to lower the embodied carbon in the building, they're trying to switch to the recycled steel stud. But we're already lower than that by 25% than the steel one, the recycled ones.
Mm-hmm.
The other benefits you're going to get from the biostud is the acoustic and thermal performance.
Yeah.
So we've done a lot of acoustic testing, and we've done it like for like. So we've actually constructed steel stud walls, tested that in one facility, and then constructed the same type, the same configuration, but with our hemp studs in the same facility using the same acoustic equipment.
Yeah.
Uh, Across those tests, where 1 to 2 decibels improvements, and that can make a difference in an office setting. Now, if you
Absolutely.
compare it with the literature of the steel stud manufacturers, we're actually 5 decibels better.
Mm-hmm.
I think there's some discrepancy, depends on the acoustic facilities that you test at. But just going on the like for like, we're at least 1 to 2 decibels improvements. And then thermal performance. Steel transfers heat and cold very quickly. The cold bridging, the heat, it's not great. So with ours, there's that, like I said, that dampening effect, because you're using natural fibers.
Mm-hmm.
So you're getting a better thermal performance there as well.
Yeah.
So then onto the pilots. We did our first international pilots, because we're London based. We did our first one in New York, and that was in partnership with the NYC EDC, the Economic Development Corporation.
Mm-hmm.
They don't consider themselves as a government agency, but they act like one, and they report to the mayor of New York. They have a sustainability hub. One of their sites is the Brooklyn Army Terminal, and they're turning that all into, uh, I guess, a test bed for innovative materials, um, ways to lower carbon. And so
Mm-hmm.
we're one of the first pilots in that facility.
Yeah.
So if you ever go to Brooklyn, you can go see 2 demonstration walls that we built there. And yeah, we did that in a day, just constructing the walls. Pretty simple, and yeah, they're on display there. Our next pilot actually is in London, with a large university.
Mm-hmm.
They have this whole science park project, which is a 5-year plan, and already they've acquired 2 buildings and they're retrofitting those.
Mm-hmm.
Works are underway already. We've actually provided around 50 studs to them, and they're putting those studs in a reception area,
Mm-hmm.
consisting of 4 walls, and this area will be for the general public to see, and actually we'll be installing those later this month. So that's
Mm-hmm.
kind of our next pilot, and then we've got a few other pilots that we've secured, mainly in the UK.
Hmm.
and also in the kind of areas of office retrofits. So one is building out a multi-faith room, a kids play area in the office, and they want to use more sustainable materials. So that's a nice
Yeah.
little project for us to get involved with. And then another is actually a residential high rise, but they have a nursery built into it.
Hmm.
So we're
Nice.
involved with the architect firm there, and they want to focus more on using sustainable materials. And they came across us and they said, look, we're actually using steel studs right now. Part of the plans is actually trying to switch out from those and use something that's more environmentally friendly. That's their first thought, but also offer acoustic and thermal performance
Yeah.
in the walls. So those are kind of the pilots that we're seeing right now, and we're focusing more on the retrofit market because uh, we see there's obviously tons of existing buildings right now, and in offices you're getting a turnover of tenants, so and they want a different configuration of their office.
Exactly.
Sometimes they want open space or they want more meeting rooms
Hmm.
or individual offices. So you're going to have tear downs and rebuilds of internal partition walls. So we see a great application there. And then kind of that leads on to maybe the retail sector. You're getting retail fit outs. Again, there's a turnover of tenants and switch over from uh, long term to maybe short term leases.
Yeah.
You get like pop-up shops, right? And so you may want a different configuration of the walls. So those kind of the areas that we're focusing on in terms of doing the pilots and then trying to build larger contracts and long-term relationships with the customers.
Yeah. I mean, hopefully that's the goal. And especially when it comes to just someone knowing that specifying this particular product in terms of its availability, right? Like even right now, in terms of your go-to market, you're very welcome, right, to working with distributors, merchants, anyone wanting to basically stock on a alternative to something that is in high demand for these kinds of projects. It's there, right? The availability is critical and well, it is lightweight by nature too, right? So in that sense, it maybe is easier for the back.
Yeah.
I've kept hearing these conversations around exoskeletons. Not sure how adopted or how soon that's going to be a thing in that sense. But one thing that actually came to mind, and I'm curious to ask you is. One thing I've seen quite a bit with reclaimed materials being a thing. And depending on the process of, say, a tear down, one might be guided to know that, well, hey, the materials in the space actually can be repurposed. And so, what does that look like for biostuds? Is that a future? Is that the case?
So I think when we came to create this product, we wanted to do all the things that a steel stud has, at least match it on performance, or exceed it in certain areas. And with the steel stud, you can reclaim that, you can recycle it. It does get tricky, pulling away from the plasterboard in some cases, but there are people doing that. You can reclaim it. So we wanted to do the same thing. And actually, when we speak with contractors, when they have it in their hands, they feel like, oh, actually, it feels more like timber. You know, the feel of it. It's not
Hmm.
doesn't have sharp edges, and that's another good thing is that you don't need to wear protective clothing or gloves because we don't have any sharp edges compared to a steel stud.
But for the
But when
sake of
contractors,
for the sake of disclosure, always have your PPE. So we can't advocate for that risk. But yes, but that's lovely.
yes,
Yeah, for sure.
when the contractors have it in their hands, they feel like, oh, actually, this feels more like a timber product. So when you have a timber product in your hands, you feel like actually I could reuse this. I could turn it into maybe a piece of furniture, or can it be? reused in another part of the build, right? And I don't think you get that sense with a steel product. You feel like, oh, take it out. Either it goes into landfill or you
Yeah.
don't know what to do with it again, right?
Hmm.
So I think we get that feedback from contractors when they have that in their hands. They feel like, oh, I could potentially reuse this.
Yeah.
Now, we've also been working on making it circular. So the binder that we're using is actually commonly found in MDF products.
Okay.
And you can't really separate the binder away from a natural fiber. So what they do is they shred it down and recycle it into itself. So just
Yeah.
make another MDF board
Yeah.
or a different product. So we can do the same thing with the biostud. We can shred it down and turn it back into itself, or into another profile, or even just as a board itself,
Hmm.
right?
Yeah.
So I think, and that's the key thing that we've looked at. Now, you do get some people who maybe a bit naive, or don't really know how it all works in construction. They ask, oh, is it biodegradable? And, can it go back into the ground? And you don't really want a kind of a structural product to
Yeah.
be biodegradable.
Like those wires from the electrical, yeah, on that car, for example, totally. Uh,
Yeah, yeah. I mean, I think you want to show cases where it can be circular, and where you can reuse the product. I think first and foremost, if you can take the stud, and if there is a tear down, how can you repurpose the stud in somewhere else, right? I think that's our
yeah.
goal. We want people to think about that. If not, then how can we recycle it? And so we thought about that. There are processors, there are recycling facilities that can take, our product and shred it down and then turn it back into a product. They just pelletize it,
Yeah.
and then, we can reheat it and then turn it into maybe a board.
Hmm.
So we have been thinking about that. And that probably goes back to the top of the conversation that we had. People are advancing the circular story and the narrative,
Yeah.
and thinking about, well, yeah, we're using this low carbon product, but we want to think about end of life and how can we reuse it again,
Yeah.
or at least recycle it as well.
I mean, fundamentally, it's about making it easier to do that, and to know that, the material itself doesn't need much of an upkeep. Even just, as you mentioned, like concerns around biodegradability made me think, should you have a label that says does not require watering, right? I mean, as you maybe have it into the product in that sense. And so, yeah, absolutely. And I mean, for now, we've mainly seen it more from a regulatory standpoint, where maybe the encouragement comes from that side. But then also, if it just makes common sense and improves business practice, then all for it, right? It keeps on giving. The value chain just ends up scaling infinitely, almost. And so that's fun with that for sure. Um, well, as we're getting near to the hour here, I'm really not sure who's in right now, but not seeing any questions. But obviously, this would be a time for anyone who's still on to ask any questions. But I feel like we've done a good FAQ almost here as we mentioned some of the concerns ourselves. And so, yeah, that's been great. All I can say,
Yeah, I would say is that the kind of the next part of our journey is
yeah.
really to get our studs out into more projects. We're getting some good commercial interest right now, mainly from architect firms. I would say that's the dynamics there with architects and contractors is so different. The architects want to specify us because they want to show that they're using sustainable materials, they're creative by nature, and they want to explore, and very curious about how that would fit into an existing system. And
Hmm.
then where we see the dynamic shift is where, okay, they've designed they've got this blueprint, and now they've shared it with the contractors, and now the contractors are asking lots of different questions about the product itself, because they're the ones that are installing the components, and they're going to be ones held liable for the actual installation. And so
Hmm.
it's natural for them to have some reservations, and maybe not take so many risks, right? Because at the end of the day, they want to work on a project, keep it on time, keep it on budget, and move on to the next one, right? I think that's kind of their model. And there
Yeah.
will be some contractors that are also sustainability focused as well. And so
Hmm.
that's where, we have to work between the two stakeholders there. And then also you've probably got the building owner or the property developer, and they've got their kind of agenda as well, whether they are focused more on cost and getting the projects completed, or whether, they also have um, net zero targets or specific ESG goals. They could push that down to the design team and then filter down to the contractor. So we're having to work with different stakeholders and understanding, where they're coming from. How do we fit into that? Because I think we've spoken to quite a lot of contractors that are be like, no, I'm just focused on cost, and if it's not the same price as steel stud, then it's not for me, which is
Right.
fine, because that's a different type of project. But then there'll be ones where they do want it to have a green certificate. They do want to promote the agenda of sustainability and having a low carbon footprint. And so those are the types of stakeholders that we're having discussions with right now. And so the more that we can do around that, and then hopefully it shifts then the conversation to contractors that are not thinking about that. And then also then you've got the regulatory um, embodied carbon limits coming down as well, and that hopefully should accelerate things. But this
Yeah.
this this is a good thing for us to at least start with a group of um, like-minded people who want to focus more on the sustainability side, and
Yeah.
then hopefully filters out into the market.
Absolutely. Yeah, I mean, it really isn't a question of whether we should or not, in that sense, because like the trajectory for doing it, just like you mentioned, your introspective journey for sort of, what would be something that excites you, right, as you look into your next venture. And the origins of that story were actually very powerful to kind of share that perspective because it fundamentally is about sort of what is better for the future. And in that sense, it's not just going to happen by itself. And so it makes total sense to try and harness, what is available in that sense and package it in a way that is easy for people to use. And so you've done it. The product is there, it's being piloted. So like it's actually very realistic and even understanding how it's shaped. So that's all part of it. So yeah, let's hope for a scaled in adoption and right now we don't have enough time on this, but with method and build, that's a big part of the mission too, is what does the discovery of alternative building products mean? And more so from your perspective as an operator in the go-to-market space of things, right? So even your background in certain working with these very large marketplaces kind of proves that there is this nuance of discovery that is ever prolific now, especially. And so it only gets to be more interesting. Um, but Kit, thanks a lot for this. I think this was very insightful to kind of give a glimpse into the realistic perspectives in adopting products like these and how really it's not any lesser. If anything, it's more. And for me, the acoustic part stands out the most because those are things that are something we definitely feel, right? And so it's great that it actually is a plus on that compared to alternatives. So I'm very excited for it.
Yeah,
Well,
thank you for having me.
yeah, no, it's been a pleasure. And hopefully we'll do it again, maybe in a different context and maybe with other guest speakers as well, who might want to chime in because it is a very in-depth topic too. So maybe excited to share future projects that you'll be on, where the realistic considerations of the product are worth sharing. Uh, but for the audience, so we're at the hour here. Just want to leave. So maybe for anyone who's been tuning into these until now, or just as a thing that I'd like to do with these shows, is to have some kind of resource that we can uh, share that's useful. And I tend to just kind of browse all sorts of organizations and learn what they're all doing. And I thought of sharing this one for today's session. So the Building Energy Exchange, I believe they're based out of New York, if I'm not mistaken. But they do a lot of great programming for lots of things, especially on the education and training side. I myself actually went through one of their programs for their passive house certification stuff, and it was very in depth actually. So learned quite a bit from there. But something they've done together with a few other organizations, but the Future Housing Initiative, they've done this interesting report where they basically shared a framework for how to assess multifamily buildings and to look at it more from dimensions that help uh, operators, anyone more on the facilities management side, get a better sense of where they stand. And I thought it was very practical. And, you can imagine if you choose a biostud, for example, you might score a little bit higher because the VOCs are a thing that aren't there, and many other things to do with like the noise pollution, all that stuff. That all adds to some of the things where they, segment things. So resident experience score would definitely touch on the air quality, noise pollution side, but probably also on the health risk score. So that QR code definitely gets you access to that PDF. And another thing is, I thought this was cool that we can do this. Not all the AI tools do this now, but I thought of uploading this PDF into a ChatGPT instance. So for anyone maybe checking this and seeing it interesting, this actually links you directly to a ChatGPT instance where this document is already loaded up. And I myself found a lot of joy from learning faster and getting to kind of the essence of whatever it is I'm trying to learn from by having conversations with the resources. Not that I don't read them, I sometimes do, but sometimes you want to get to the gist of it or contextualize it in a way that you're more comfortable with or familiar with. And I find this interaction to work really nicely. So I advocate for it, and this is one way one could do that. So this link gets you to a chat instance of doing that. Um, Nothing else to share here other than thanking everyone for being here. Kit especially. Awesome conversation. And until next time.
Thank you
Mahalo.
all.
Yep.
Take care.